the first one is 2 rows, 2 columns. Second one is 2 rows, 3 columns. So can we multiply?
Yes.
Yes. These numbers match, so we can multiply. How big will my final answer be? 2 by 3. 2 rows, 3 columns. So we have to figure out those numbers. So this is the number in row 1, column 1. So to get it, you take row 1 times column 1. Right? You multiply the corresponding numbers, then add them together. So 3 times 1 is 3. Negative 4 times 6 is negative 24. So when we add those, we get negative 21. So now we keep moving along. So the next one. This is row 1, but column 2. So I'm going to take row 1 times column 2. So 3 times negative 3 is negative 9. Negative 4 times 0 is 0. Add those together and we get negative 9. Moving down my list. This is row 1, but column 3. So I am going to take row 1 times column 3. So 3 times negative 4 is negative 12. Negative 4 times negative 2 is positive 8. Add those and we get negative 4. You guys with me there? So let's keep going. We do this next one. So this is row 2, column 1. So I'm going to take row 2 times column 1. So 1 times 1 is 1. 7 times 6 is 42. So we get 43. Then we have row 2, column 2. So 1 times negative 3 is negative 3. 7 times 0 is 0. Add those and we get negative 3. Finally, we have row 2, column 3. So row 2 times column 3. So 1 times negative 4 is negative 4. 7 times negative 2 is negative 14. So we get negative 18. Does that make sense? Mm-hmm. Do we need another example? Any other questions from either assignment? So I will collect that then. And we are just doing some more practice today with using a matrix to solve a system of equations. So we need our notes. We're back to section 5.2. I'm jumping around a little bit. Let's say I give to solve this? Using a matrix. What do we do first? Yeah. When we set up the matrix, we need the x and y on one side, and you would add your 5 and 3 over. A lot of times we don't have to worry about that, but it was an issue here. So when you set up your matrix, your first row would be 6, 1 equals 5. Second row, 5, 1 equals 3. Okay, where do we start?
The first one.
We need a 1 in row 1, column 1. How can I get that 6 to be a 1? Okay. The easiest way, maybe not always the prettiest, but the easiest in that it always works. Anytime you want to get a 1, just multiply by the reciprocal. So I'm going to take row 1 times 1/6. So what's happening here is row 2 stays the same. Everything in row 1 gets multiplied by 6. So 6 times 1 over 6 is 1. 1 times 1/6 is 1/6, and then 5/6. Okay, what's the next thing? Yes. We need a 0 everywhere else in that column. So I need this 5 to be a 0. The easiest way to get a 0, so that's row 2. So we'll start with row 2. It's a positive 5, so we have to subtract 5. But is it legal just to subtract a number from everything? No. So what do we have to do with that? 5 of row 1. So row 1 does not change. Row 2. So you have 5 minus 5 times 1. 0. 1 minus 5 times 1/6. Should give us 1/6. 3 minus 5 times 5/6. What's that give us? What do you get? Okay for this.
Are we doing
What do we need next? Yeah. Okay, we're trying to get 1s on the diagonal. So we do one column at a time. We get the 1, we get the 0. So now I need this 1/6 to be a 1. We've already said, easiest way to get a 1 is multiply by the reciprocal. So we have to take row 2 times 6. So row 1 is not changing. Zero times 6 is 0. 1/6 times 6 is 1. Negative 7/6 times 6 is negative 7. We are almost done. What do we have to change now? So, best way to get a 0, we're changing row 1. So start with row 1. It's a positive 1/6, so we have to subtract 1/6 But we can't just subtract a number, so it's 1/6 of row 2. So we have 1 minus 1/6 times 0, which is still 1. 1/6 minus 1/6 times 1, which is 0. 5/6 minus 1/6 times -7, which gives us a 2. Okay. So what's my answer?
X equals to y equals
7. Is that okay? I want to try one that has 3 equations. What would my first row be?
2, 0, 6.
But we don't have a z, so we have to put a 0. Second one, 1, 1, 1. Third row, okay, so my goal, remember, is 1s on the diagonal. So what that means is I have to get these 3 numbers to be a 1 and 0s everywhere else. We have to do 1 column at a time. So first thing, I need this to be a 1. How do we do it? So row 1 equals 1/2 row 1. Now what do we need?
0 below
Okay. So we actually have to get both of these numbers to be zeros, right? We can do it in 2 separate steps. I'm going to go ahead and just do it all at once, but I'll do 1 row at a time. So if I start with row 2. So to get a 0, we're starting with row 2. It's a 1, so we have to subtract 1. And we need to use the row that we just got a 1 in that entry. So I just need to subtract 1 of row 1. Just row 2 minus row 1. So my first row didn't change. Second row, 1 minus 1 is 0. 1 minus 1 is 0. 1 minus 0 is 1. 1 minus 3 is -2. Anyone have a question about how I got let's go ahead and fix row 3 as well. So it's currently a 3, so we have to do row 3 minus 3 of, and we're going to use the row 1 there. So we have 3 minus 3 times 1, which is 0. 4 minus 3 times 1 is a 1. Negative 1 minus 3 times 0 is negative 1. And 13 minus 3 times 3 is 4. Okay, my first column is good. What do I need to do next?
Get the second one to be 0.
We need ones on the diagonals, right? So I want this number to be a 1. There's a really easy way to do that. What do you notice about the bottom row? Does it matter which equation's on top? So we can switch any 2 rows. That was the other legal move. So I'm just going to say row 2 equals row 3. And I'm going to flip those 2 rows. So that's pretty good for me, because now I have my 1 there, and we want zeros in the rest of that column. And this one's already a 0, so all I have to do is get this to be a 0. How can I get that to be 0? So in row 1, it's a 1, so subtract 1 of row 2. So just row 1 minus row 2. So 1 minus 0 is 1. 1 minus 1 is 0. 0 minus negative, so 0 plus 1 is 1. 3 minus 4 is negative 1. We're close. We want ones on the diagonal, and I have it. I want zeros everywhere else, so that these zeros are good. The last thing we need to do is both of those need to be a 0. Okay, so for row 1, if you want to get a 0, what could you do? Let's just subtract row 3. Why don't I want to add row 2?
Because then you don't want them.
Yeah, it undoes some of that work we've done. So let's subtract row 3. So 1 minus 0 is 1. 0 minus 0 is still 0. 1 minus 1, 0. Negative 1 minus negative, so negative 1 plus 2 is 1. All right, row 2. That's a negative 1, so to make it a positive 1, all we have to do is add row 3. So 0 plus 0 is 0. 1 plus 0 is 1. Negative 1 plus 1 is 0. 4 plus negative 2 is 2. leaving a final row. So we have x equals 1, y equals 2, and z is negative 2. Okay, we can see this is a little bit longer than a system with 2 equations, but not that much longer. When you think about elimination, when we went from 2 to 3 equations, we really added a ton of work to it. I'm not going to do 4 equations, but 4 and above is really when this method is way faster and substitution and elimination is way longer. But this will be as far as we go with it. Questions? So here's the deal. This is kind of tricky, but it's really hard because there's multiple ways to think through problems. And unless you're actually trying some on your own, I don't think you're really going to get it. So I'm going to stop, and I want you guys to